Hello students, this is Ms. Medina, and in this video we're going to talk about the applications using polynomials. I guess I should have erased this before since it's not quite correct. The first one says write an expression that represents the area and the perimeter of this rectangle. So for the area of a rectangle is going to be the length times the width, correct? And for the perimeter is going to be the length 2 times plus the width 2 times, right? Because we have 2 lengths and we have 2 widths, a total of 4 sides. So we can say that this one is the length, and it really doesn't matter which one you decide to call which. We'll call that one the width. Clear? So for the area, it's going to be the length, which is 7x plus 10, times, so 7x plus 10 is a quantity that comes together. So that's why we have to wrap it in parentheses, times 4x plus 8, which is also another quantity that comes together. All right, so this is a 2 by 2 box. And for the area, we're multiplying. So it's going to be 7x and a positive 10, 4x and a positive 8. All right, so for here, 7x times 4x is going to be 28x squared. For over here, it's going to be 7x times 8, which will give us 56x. This one right here is going to be the 10 times the 4x, so that's 40x. And the last box over here is the 10 times the 8. Well, that one's easy, 80. Now, do we see any like terms? Yes, we do. We see them right here. Both of them are positive, so we're thinking 56 and then a positive 40. Together, they make 96. Right, so the area, the expression for the area, right, is going to be 28x squared plus 96x plus 80. All right, so now for the perimeter is going to be twice the length, and which one we said was the length? The 7x plus 10. And yes, once again, it's a quantity, so we're wrapping it in parentheses, plus twice the width, and the width is 4x plus 8. All right, so the first thing we need to do is we need to get rid of these parentheses. We can't just ignore them because we actually have a number in front that needs to be distributed. Well, the 1 also gets distributed, but this one we clearly have to multiply. All right, so that's going to be 14x plus 20, right? 2 times 7x, 14x, 2 times 10, 20. And over here, it's a plus sign, so we can bring it. It's not going to change the signs. So 2 times 4x is going to give us 8x, and 2 times 8 is going to give us 16. All right, so after we distribute, we now identify like terms. Okay, it's 8x and it's a positive 8x. And this is a positive 20 and a positive 16. 14x plus 8x is what, 22x? And 20 and 16 should be 36. All right, so this is the expression for the perimeter. All right, rewatch if you need to, but once again, this is a type of problem that will be on the test. Find the expression for an area and for a perimeter. You're designing a rectangular flower bed that you will border using brick pavers. So as you can see in the picture, there's your garden, and then those are your brick pavers all along. So the width of the border the width of the border around the bed will be the same on every side as shown. So let's see what's shown. It's a good color. Yellow? Can we see yellow? No, we can't see yellow. Blue. Okay, so from here, from not including this outside paver, notice where the line starts, okay? From here to here is 6 feet. Yeah? So that means from this paver to this paver is 6 feet. And then this over here, see green, orange, this distance from here to here is how much? X feet. So that means this distance down here, right, from here to here is also X feet. Wait a minute. So if this right here is X feet, then this one right here is also X feet. Same thing here. So you see, you have to be able to decipher the information that's being given to you. Now, I'm gonna have to use green or purple. All right, so from this 1, 2, 3, these pavers right here are 5 feet. So that means these pavers here are also 5 feet. Right? Up to here and up to here. But then what about this leftover distance? Well, that paver is, if this right here is X feet, then this right here is also X feet. Same thing here. It's X feet. And same thing here, X feet. Okay? All right, so that's a lot of coloring, but we want a polynomial, write a polynomial that represents the total area of the flower bed and border. So we want an expression that's going to give us the border. So this is where addition and multiplication mix in, right? So focusing on just that top portion. Let's get rid of some of this distraction, wonderful information. Oops, not that. Orange. All right, so we're just talking about this total distance from this edge of the border all the way to this edge of the border, right? That includes, we'll say this one is the length. Clear? Oh, I really wish I had white so I can get rid of these words because they're in my way. All right. Well, how long is this length? Well, let's think about it. The distance includes this X distance right here, the 6 feet, which is this part here, plus another X over here. So the total distance is going to be X plus 6 plus X. And so we're a little bit better than that, right? Combining the two X's. So that's going to be 6 plus 2X. That's the total distance of the length. Okay. So now let's talk about a width. So the width is going to start here and it's going to go all the way down here, including the paver. Clear? Now we know this is 5 feet. Okay, so let's get rid of some distraction. As wonderful, as helpful as it was. Well, hopefully you wrote this down in your paper. You don't have a digital pencil like me. All right, so we know from here to here is 5 feet, but we still have to account for this length of this paver and that paver. And so we said this one was X and this one is also X. So our width is going to be 5 plus 2X. There you go. And how do we find the area of this flower bed and border? We multiply. Area is length times width. So the area is going to be given by 6 plus 2x. Remember, it's a quantity. Times 5 plus 2x. Why aren't we adding? We're not adding because they want the area, and area means we multiply the length times the width. And how do we multiply polynomials? Well, the one method that we've been using in class is the area model. All right, and yes, we need scratch paper for this. All right, and then we have the 6, a positive 6, right? And a 2x, which is also positive, the 5 and the 2x, and everybody's positive, right? Happy? And I'll do the coloring because make sure that you understand where each 2x came from.
Let's go.
Right. Okay, so now let's continue. 6 times 5 is going to give us 30. 6 times 2x is going to give us 12x. 2x times 5 is going to give us 10x. And 2x times 2x, remember we're multiplying, 4x squared. We have like terms? Yes, we do. That would be this one and that one. And so remember, in our brains, we're thinking a positive 10, a positive 12, so that's 22. So 10x, remember we're not multiplying anymore, we're adding, so it's just 22x. All right, so the area is going to be, oh wait, let's write it over here, right? 30 plus 22x plus 4x squared. Now, did you notice what's wrong with this? It's not in standard form. So we have 3 terms. We have this one, that one, and that one. And 30 doesn't have any variable, so it's just degree 0. 22x, x is the variable, degree 1. And 4x squared, x is the variable, exponent 2, so this is degree 2. So really, we have this out of order. So the area model would be 4x squared plus 22x plus 30. I mean, it's not wrong, it's just not in standard form. Right, that's the area. Is that all we had to do? Yes, this is the model that represents the area of both the garden and the border, everything. Right. B, find the total area of the flower bed and border. Okay, so that means that we're using the expression that we just found when the width of the border is 1.5. Width of the border, remember width of the border is x, so that means when x equals 1.5. Okay, so it's going to be 4, right, 4x squared, so 1.5 in parentheses squared, plus 22 times the value of x, right here, and then plus 30. Okay, let me get the calculator. All right, I get 72, and so it's going to be feet squared, right? Because the length is in feet. All right, so let's do a unit analysis. We know the area is equal to length times width. The length is in feet, and the width is also in feet. So when we multiply them, we get feet squared. So that's how we know. That would be the full area. Alrighty, I love this problem. We have to find the expression that represents the area. Since it's a rectangle, right? The area that we're going to be using is the length times the width, not covered not covered by the mailing label. So that means that we want the area of the envelope that's everywhere but the mailing label. All right, so this is everywhere that the mailing label is not covering. So we want the area not covered by the mailing label. Now, if we use this length and this width, when we calculate the area, we're going to get everything, including the label. So that's not what we want. If we use this one and this one, then we're going to get the area of the mailing label, and that's not what we want. But you'll notice that if we get the whole thing, right, and then subtract, where's the eraser? Subtract this area, look, we get the area of the envelope that is not covered by the mailing box. So this problem is actually a subtraction problem. Right? We need to subtract out the area of the mailing label. So first we're going to find the area of the full envelope. And then we're going to do minus the area of the label. And that'll give us the area of the envelope. Hold on. Not covered by the label. Whew. So this is two separate problems. Okie-dokie. So I might have to write smaller. I hope that you can squint at your phone. All right, area of the full envelope is going to be given by this one and that one. Here we go. It's going to be a 2 by 2. All right, it's going to be 4x plus 4 and 6x and a positive 5. All right, let's see. So now multiplying, we're assuming we're good at this. 4x times 6x is going to be 24x squared. Remember, we're multiplying. The 4x times the 5 is going to be 20x. The 4 times the 6x over here on top is going to be 24x. And the 4 times the 5 is going to be 20. And which ones are like terms is going to be those two. All right, and 24 plus 20 is 44. All right, so then this one becomes 24x squared plus 44x plus 20. That, dearies, is the area of the full envelope. Notice the parentheses. I'm doing that on purpose. All right? And so we need to subtract the area of the label. Now the label is given by this length and that width. Ready to multiply again? Oh, my box got smaller. All right, x plus 3 and x plus 4. All right, x times x, x squared. X times 4, 4x. 3 times x, 3x. 3 times 4, 12. And these are like terms. All right, 3 plus 4 is going to give us 7x. All right, so combining the terms, it's going to be x squared plus 7x plus 12. And this, my dearies, is the area of just the label. And we said that if we take the area of the full envelope and subtract the area of the label, we were going to get the area of the envelope not covered by the label. So guess what? Minus. This is kind of a really big negative sign, so let's not get too. We're subtracting, and when we have a negative sign, remember, we need to distribute it before we do anything. All right. All right, there's an understood 1 out here, so then we can just ignore those parentheses. But this is going to be negative x squared minus 7x minus 12. Now it's time to combine like terms, and we'll just get to the nitty-gritty, right? So this one and this one. All right, so when I look at this, what do I see? I see a 24 that's positive and a negative 1, right? Negative 1x squared. So that's 23. So this is going to become 23x squared. All right, the double hash marks. I see a positive 44 and a negative 7. Once again, this is my brain or my calculator. And what is that? 337. So plus 37x. And then lastly, let's do a squiggly on these. All right, so when I look at the two constants, I think, oh, that's 20, a positive 20, and a negative 12. When I combine those, I get 8, positive 8. And there you go. This is, in green, the area, oh come on pen, work with me, the area of the envelope not covered by the label. Booyah. All right, I hope you enjoyed the video. I hope it was instructive, and once again, each of these problems you will face again. Okay? The area when you have to add the border, and the area when you need to subtract something inside of it.